Did everyone show up?
Hello everyone, I welcome you all to today's seminar. Thank you very much for joining in. I'm really pleased to introduce today's seminar speaker to you guys. We have today with us Professor Ujjayant Chakravorty, who is a professor at the Department of Economics at the Tufts University. His primary research area is resource and environmental economics, and he's been looking at issues related to water depletion, energy access, and longer-term impacts of electrification. So just a little bit about logistics. So Professor Chakravorty, you would have an hour to present today. Would you like to read the questions alongside? All right. So let's just keep the questions as he takes us along the slides, and probably push the more substantive ones towards the end so as to not break the flow of his presentation. Professor Chakravorty, the floor is yours.
Thank you, Nisha. Thank you for inviting me to give this talk. Really appreciate it. Yeah, stop me anytime. We'll do it as we say, econ style, which means you can interrupt me anytime you want. Don't leave your questions till the end because you might forget, and I might not get the benefit of listening to that question or comment. So so this is a paper we are I think almost at the end of our sort of research and writing, and we want to submit it. So it's really good to get your feedback before we send it to journals. This is a paper with three other people. Kyle Emmerich is my colleague at Tufts, and Humnath Bhandari and Ashraful Habib are basically, Humnath is an economist, and Ashraf is an agronomist at the International Rice Research Institute in Dhaka. So so basically, what is the problem? And we have the problem of groundwater depletion is essentially the problem of dry season irrigation. So this is a slide. Sorry, this is a slide that shows you there are three seasons in Bangladesh for rice production. So Aman, Boro, and Aus. Aman is monsoon rice, sort of July to December. Boro is dry season rice, January to May. And there is a Aus, it's the third season. I'm not sure how many. I know in India there are at least two seasons, but I don't know if people in West Bengal call 3 seasons. Three? In some form. Okay, very nice. It's actually called by the same. Oh, really? Oh, very nice. Thank you. So exactly. So, but what's interesting here, though, is look at the explosive growth in dry season yields, production from dry season rice. This is the Boro rice. The output on the y-axis and years on the x-axis. And basically, I think if you look at rice production in other countries like India, it's same idea. I mean, historically, 30, 40 years ago, most people would be growing, monsoon rice. I don't know how many people do dry season rice, but all this is coming on the back of groundwater irrigation. And this is really important because, governments are especially Bangladesh. Again, I will not claim to speak about India too much, although I grew up here. But I think the similar sentiments exist, which is that governments are very worried about rising prices of rice. More people eat rice. They do not want revolt. So food self-reliance is very important, and that is achieved by groundwater irrigation. So this is really very important in terms of national security, especially in the area of food. So, however, the other, of course, flip side is you're extracting all this groundwater, and that is leading to depletion of groundwater levels, right? So that's the problem we are studying. So here, number of irrigation tube wells rose 15 times in Bangladesh between 1982 to 2010. In India, you can read Tushar's book, for example, anarchy, whatever it's called, same idea, right? Explosive growth of tubal irrigation in India. And rice self-sufficiency is considered a huge policy win. Okay? So there are other problems with this situation, which is, and I think hopefully this paper would make you think about them. Well, firstly, groundwater is open access. So I drill a hole in the ground, I take out as much water as I want. Of course, I'm limited by the amount of electricity or I can get and I can afford. So that may lead to over extraction. Secondly, pumping uses cheap diesel and electricity, so environmental externalities. So this paper is really the one dimension of this, and which I think people don't often realize. They think, okay, groundwater extraction, water depletion, but along that groundwater extractions, you are using either diesel or electricity. And increasingly there are concerns that these fuels lead to carbon emissions and therefore global warming, right? So a big a lot of thinking among economists in the US, for instance, focuses on carbon emissions from different sources. Michael Greenstone has written a lot about this. Basically, the idea that let's look around the world and see where is the cheap, low-hanging fruit. How can we reduce carbon emissions from different sectors of the economy, and at what cost? So this paper, I think, contributes to that in terms of reduction of environmental externalities. So the policy goals are use water more efficiently. And, at least in Bangladesh, the agricultural minister has gone to farmers and said, look, don't grow rice in the Moro season, in the dry season, grow something else, lentil or other types of crops with very limited success.
Have farmers been doing rice and dividends? Rice is by some government that we have it in India.
Right. That's a really good question. I do not know whether there are distortions like buying all this rice at prices in Bangladesh. I'm not sure. But I know that, at least from a casual observation during many trips, is they eat a lot of rice. And maybe there is a price. Yeah, that's a really interesting question. I mean, on the one hand, they're telling you not to grow rice. On the other hand, maybe they're buying that rice at some minimum price. Not clear what that might.
Exactly, matter for policy.
Exactly. Absolutely. They're buying that. I haven't heard much discussion like we see in India about these fair price. Pardon me?
And
okay.
There's some preference towards that price. There's the
Well, definitely. As a Bengali, I can tell you, we love to eat rice, and
but particularly towards that variety.
Varieties. Interesting. My colleague works a lot on different types of varieties. I don't think there are only a few varieties that are grown predominantly everywhere. They are trying to, like Erie, for example, they have new varieties that are maybe more flood resistant. They have other types of characteristics. They can grow in bad environments. But in terms of taste, I'm not sure that the consumer has clear preference for varieties. Of course, all varieties basically use the same kind of water. You don't see a lot of heterogeneity within the village in terms of people growing. You growing variety, IR8, I'm growing IR26. I don't think we've seen much of that. Everyone has very homogeneous production processes, yields, preferences, etc. But yes, in general, the whole country loves to eat rice.
encouraging not the problem. The problem is excellent. It's on the groundwater. See, more is not the best.
Well, producing more is what's leading. What's leading to the externalities that we are studying. Right.
Here, price is
Exactly.
Which is why for electricity in the climate.
See, it's already saturated when it comes to producing in the monsoon. There is no more scope for increasing production. The only scope for increasing production is in the dry season.
So, now,
Absolutely.
that is the reason that they intended.
Yes. Yes.
There is nothing wrong with that.
Nothing wrong with that except the externality.
All the pricing is possible.
If you did not have groundwater irrigation, you would not have increase in food production, and so there'll be other problems, right? Exactly. Exactly. That's why we are studying this problem. So, so basically, the point I was making here is that government efforts to reduce dry season rice production has not succeeded. We are still producing a lot of rice, and it's very important for national, from a national perspective. Okay, so what are the sort of mechanisms to conserve water? If you look at the literature in economics, yeah.
And because Bangladesh is a very
Right.
can have a brand.
Right, right. That's a really interesting question. How much of rice? I mean, if you look at the slide, which I showed you in a second, yeah. So you see, what you're saying is Oman is subject to a lot of flooding, right? Yeah. So maybe part of this difference could be caused by flooding and the fact that some acres are not in production. Yes. Yes.
And this was conscious was
Right.
when always instead says it probably
Much more difficult. Exactly. That's a really good point. Yes.
control the cannot. Once plant is applied and
Right.
that's where you see then the push happens. And they basically give a lot of
Right. And also very big as well. So one of the we have an earlier paper. If people are interested, you can look at it. That paper is also very on the same technology I'm going to talk about. But this is in an area called Barind area, which is primarily on Rajshahi, where the water tables are much deeper. So individual farmers find it not economical to, essentially, they are not able to afford those pumps. So the government has gone and drilled basically powerful pumps. The interesting feature that we explored in that study is that those pumps use debit cards. So I can be a farmer. I can go and get a debit card with 500 rupees or 1,000 rupees. I can theoretically go into the pump, put my debit card, and take the water and channel it to my field. However, in reality, what you see is that usually only 3 cards are used. It's the guy who runs that pump keeps 3 cards in his pocket. It's usually a he, not a she, and they use that the pump to they use the cards to take off water, but they charge people fixed price. So you still pay by the acre that you're irrigating, and so the pumps essentially the cards do not lead to an increase in volumetric pricing. So this is another paper we have done, which basically compares areas where there is a large penetration of these debit cards versus areas that are low penetration cards, and whether this technology that I'm going to talk to you about saves water or not. Okay, so basically, if you look at the literature, there are different mechanisms to conserve water. Well, one is technological change. this is a lot has been written in the United States and other countries. Maybe let farmers adopt, conservation technologies. Zilberman and many other people have talked about this. Collective action, Elinor Ostrom's work. Rationing, there's a new paper, if people are interested in water, this just came out in the Journal of Political Economy, where they talk about, rationing primarily in Rajasthan. And the fact that farmers' production production functions, there's a lot of heterogeneity among farmers. And so rationing may be good from an equitable point of view, but it basically restricts people who are much more productive. So if your demand curve is way out, my demand curve is way close to the origin, the same rationing will impact these two farmers in a very different way. So this is a very nicely written paper that talks about rationing as a way of conserving water, improving water efficiency. Transferable quotas is another idea, primarily again in California, that maybe farmers who don't need that much water can sell their quotas to other farmers. And therefore, you achieve efficiency. And then, many years ago, Jim Buchanan wrote a paper on, what happens in the case of monopoly. If you have, for example, if you tax monopolies are already producing too little. If you tax them even more, they may produce even less, and therefore they're farther away from the optimum. So that was a Buchanan paper back from, I think, 1990s. Okay. So what does this paper do? In many countries in South and East Asia, local water markets are natural monopolies. So the context I'm going to describe to you now is not the Rajshahi context where the government comes and drills tube wells in very deep, deep water areas, but these are essentially private tube wells. So someone in the village owns a tube well. Usually the average number of tube wells in a village in the areas we study is about 2.6. So 2.6 wells in a typical village. These are private tube wells, and they are national monopolies. Why? Because if you are next to me, if your farm is located next to me, you are essentially going to buy that water from me. You're not going to buy the water from someone else because it's too far away. What I'm saying. So why is it a national monopoly? Because average costs are declining. Fixed costs, high fixed costs are drilling and pumping, and tiny plot sizes. So the plot sizes are very, very small, right? And so therefore I can supply maybe to 15 or 16 farmers for tube well. Very different from the US situation where plot sizes are maybe 30 times in the United States. And every farmer has their own tube well. So I have a paper with my friend Somanath on this. But that's about comparing water allocation in South Asia. So anyway, so what is the research question? The first question is, who benefits from water-saving irrigation technology in the presence of monopolistic water markets? Do farmers benefit if they save on water costs? Do well owners benefit if pumping costs are not passed to the beneficiary, to the farmer? Does the environment benefit if there's less water use and therefore reduced externalities from pumping? So we are going to investigate who benefits from this technology that conserves water. So stop me anytime if you have any thoughts or questions. So what do? We essentially do a randomized control trial over 2 seasons in 360 Bangladesh villages. And we are subsidizing this irrigation technology called AWD. I'm going to explain that to you in a second. And then we contrast subsidies provided to buyers and sellers. We subsidize this technology to different groups of people in the village. So some villages will get a subsidy where only farmers get a subsidy. Some villages, only sellers get a subsidy. And some villages, we organize meetings of farmers, and at the meeting, we sell this technology at subsidized price.
The seller can also be a farmer.
Yes. Good point. Absolutely. All of these sellers are farmers as well. But we only sell it to the tuber. We are talking about a technology, which is coming in a second. It's called the alternate wetting and drying technology, AWT. You may have heard of this because I know in West Bengal, for example, I'm going to talk in a second about what that technology entails, but it's well known in many circles. Yeah.
So I was just wondering, how are these buyers different from the people who are sellers in the sense that, what decides that I have a tube well versus a farmer? Are these two types of farmers different?
So that you are actually asking about a problem that we address in the paper, where we basically have all of our people are farmers, and then someone decides to drill a well. And the idea is that you drill a well if the number of people who will buy water from you, so the total revenue is more than total cost, which is the fixed cost of electricity and getting the license, permit, and what have you. Yes, so endogenously, obviously, some of these farmers have drilled wells and are therefore sellers of water.
Yeah, in some sense that has distributional implication.
Yes, it does. It does. As you'll see in this paper, yes. In the sense that if the sellers are making money from our technology and therefore reduced use of water and electricity, then they're benefiting. Of course, this is a subset of the.
I was just wondering what's different about them than the people.
Fundamentally, what is different? I would say they are wealthier, maybe, or less poor than their neighbors. Often we have seen, again, I don't think they have collected data on their incomes, not for this project, but they often have other businesses.
Welfare sector?
Pardon me?
Are there any subsidies on drilling these wells now? People who own the wells, is it easy for them to get it? I was just wondering how the two groups of farmers are different, right?
Exactly. Or the ability to get the permits and buy and get it. Right.
Taxes.
Absolutely.
First mover. I think it's a common. Right. First mover.
Yes.
Whoever is happens to be. Can be the first mover.
Exactly. So, absolutely. And then if I'm the neighbor of that first mover, I will not drill a well.
Yeah, you have to buy it.
Exactly.
You're not sure.
Exactly. So we address that problem in our. So it's a good opportunity to do PR for our other. We have. It is possible that there is some. All of these are small plots. Each farmer owns 2 or 3 plots on average. They're all tiny plots. 26%. This is a good statistic for you. 26% of our farmers are relatives of the well owner. So the well owner's extended family is also farming. And in fact, one of the tables further down, we see in general among all of the arms of the RCT, the well owner places the pipes in fields which are their relatives, much more than those that are not relatives. Pardon me?
There's a cost.
Well, I'll tell you in a second. I haven't told you anything about technology. It doesn't cost anything, really, but maybe it is because I can choose to plant that pipe. It's essentially a pipe, relatives plot, relative, rather than someone I do not have a good. So, exactly.
That we also. The typical small.
They are all very small farmers. Yeah. We do not see large. Not see large.
That is typically the. I'll
show you. I think a 0.4.
Right.
Yeah, 0.4 acres. No, these are very relevant questions. But the answer is, it's coming in the slides. But they are very small. Yeah.
That caste their role that the higher caste people are not from what is the foreign water from the same well to the lower caste?
Well, 90% of the people are Muslims. We do not see any difference in prices. Again, that's a really interesting question you asked. We don't see much difference in the prices charged in the village. Basically a flat fee per acre. So if you own 0.6 of an acre, you pay 0.6 flat fee per season. We do not see other dimensions along which they prefer, giving water to people, etc. We haven't heard any case of farmers being deprived of water. Usually, it's very professionally done. This is actually useful to answer that question because let's understand the context. But usually, this tube well owner has one or two linemen. These are employees who every season they go and these are earthen ditches which hit the water, and they'll clean out the ditches, take out all the weeds, etc. And every day they go around the village to see, maybe who needs irrigation today, or what's the irrigation cycle. Maybe today the northeast of the village, tomorrow the south of the village, etc. So they employ a couple of linemen. The number of linemen depends on how big the command area is, how many farmers are served with the water. Also, what is interesting, apart from the fact that these guys maybe, may have an advantage in terms of access to resources, is sometimes altitude design. So if I have land that is relatively high up, I can basically, that water will travel farther. And if I dig a tube well, that's going to carry the. Okay, so yeah, we don't see any preferential treatment to secondary population. So what we are doing is contrasting the subsidies provided to buyers and sellers. And then the main outcomes that we look for experiment is for pumping. So we are reading the meters, and so we are not interested in the we are only looking at, because everything is electric. And then we are looking at water prices that are charged by the tube well owner. So this is our technology, okay? It is not a very sophisticated device. Basically, it's called alternate wetting and drying. It's not new. It's known at least for the last 40 years. In experiment stations of the International Rice Research Institute, this pipe saves about 40%. Okay, what is this pipe? It has perforations and it is open on both ends. So basically, you can make it out of an empty Coke bottle. You can take a Coke bottle, cut the bottom, make some holes, and plant it in your rice fields. And why does it save water? Because see here, this is our plot planted here. Essentially, it allows the farmer to observe the water level inside the pipe. There's a marking inside the pipe that says if the water level below this, irrigate. So it gives you better information. You recall that rice needs water sitting on the field, right? When it goes down and you cannot see the water on the surface anymore, then you may have to guess, right? So this pipe, basically, when you look into it, and there's a little net you can have here under the pipe to prevent mud, etc., from the pipe. But the moment you see that water going down to that level, then maybe the root zone of the plant will not get the water. So you say, okay, now it's time to do it. So it's basically a device that gives you information about irrigation, and therefore you may irrigate less. For example, you're more accurate in watering the crop. Okay? So experiment station, 40%, 30% reduction. If you look at the literature on AWD over the last 30, 40 years, a lot of field trials in Vietnam, Australia, China. In the field, it has not gained that much conservation. Field experience is much different than in the experiments.
So farmers tend to overwater, and that's why better information use it for.
Exactly. Yes, I'm guessing how much you need, so I'm maybe giving you more water. But if I place this pipe strategically in the village, and as a well owner, as a lineman, I might know the topography of the village more accurately, then I might place this strategically so that I know, okay, this section of I think the water is gone from here, so I can in our previous experiment also, when we were distributing it to people in areas with volumetric pricing versus areas with non-volumetric pricing, we found about a 20%. And no other changes in yields, no other change in labor use. There's some literature that says because you are now providing less water, there's more weeds, there's going to be more labor use. We haven't found that. We legislate on labor use. Haven't found any other beyond water use. So actually AWT is very important because Bangladesh under the Paris Accords is saying that this is one way they're going to reduce carbon emissions by reducing water use and questions.
How many of that's supposed to in Tufts, right? Typical, and what is the typical price and how much is the sub?
Very relevant question. So we did a survey of manufacturers to estimate the cost curve in our previous. It costs about 235 rupees. Maybe we showed up at the shops, so therefore the price was a little more expensive. But so that's about what the 100, 135, 140, and we have a buffer. About, I would say more than 100, 140 rupees. We sold these in the village at two different prices. There was not much action in the prices, so I will not talk to you too much about how much subsidy we offered. But we had 30 rupees and 60 rupees, two different prices we offered. Whoever was buy, it's a village.
And 1 pipe suction.
Oh, yeah, so no, 1 pipe is not sufficient. The average, one pipe may give you local information about that area. So we found that people would, plant like 4 pipes.
120.
Absolutely. So here is a typical, very small plot. This is just a comparison of cornfield in Iowa, and that's 1/3 the size of a cornfield. It's all our plots. And big difference. So what we found, just to give you a preview of where we are headed, we found that the subsidy led to 40% reduction in electricity. Huge margin of so first year we sold the pipes. Next year we sold more pipes. The same villages at the same prices, at the same amount. So if we sold it to the owners in that village, the next year also. No one will get it. Only provided with the tube well owner. So the effect is only when we sell this to the tube well owner, not in the villages where we sold it to the door to door. Okay. Not driven by differential take-up of the technology, meaning not driven by how many you buy. So we found, remember, there were 3 arms. One was door-to-door sales. The other one was sell to the owner, how much you want to buy and give you as many as you want. Basically, the upper limit is how many farmers you have. No one bought so many, of course. And the third arm was meetings of farmers and sell after the meeting. So the idea there was, maybe, farmers will, they'll discuss the benefits of the device and then they'll agree that, hey, this is a great idea. Let's go, buy some of these pipes and plant them strategically and so forth. And so then maybe there'll be some effect on electricity use. What turns out is that in the meeting arm, many more people bought the pipe, but there was no impact. And it may simply be a meeting effect that they thought that this is a great idea, let's go buy the pipes, but they did not. We actually found some kids playing with the pipe, using it as a cricket. So it's a heavy device.
But then not use that.
Yes. Not like.
What you have is ITT.
Yes, exactly. So, so not driven by differential take-up in technology, no evidence of pass-through of benefits from farmers to owners. And so there was no effect on prices, even after the savings of 40% in the village. That means next year, the price of water was not as nothing. Yes, that's a good point. Thanks. So, okay, so this is considered in the monopoly model that I'm going to talk to you about in a second. And the climate benefits, if you compare this study and the carbon emissions per dollar saved, it compares very well with other studies in the league. And the reason is, if you look at the economics literature in energy and development, most of the carbon emissions are from, say, the experiments are from residential use. So in the United States, you have studies where they have changed the bills that people get, electricity bills. They tell you how much, your electricity use of your neighbors and how you are doing compared to your neighbors, or other types of interventions. In Michigan, there's an interesting paper on going into homes, essentially poor homes, and telling them, we'll subsidize the upgrading of your furnaces. Okay, and would you, so we subsidize it, but pay so much money, we'll give you a better furnace, which is much more energy efficient. And they looked at the costs of those interventions in terms of per dollar per unit of CO2, and we find that this intervention is much more. There are almost no studies of interventions in agriculture and the energy use in agriculture. Yeah.
And the one we buy from them are primarily.
No, only 26%. 22% are relative.
Idea of what is.
Right. That's a good question. So with the third arm, I told you, with the meeting, we thought that the meetings will realize the benefits of this device, and therefore maybe they can coordinate on the irrigation among the farmers. The door-to-door, we thought, well, to the extent that the farmer, we didn't know, right, ex ante, that who is actually deciding when to irrigate. We thought that the farmer makes a large part of that decision, right? So if I'm a farmer, I decide, I go to the owner and say, hey, I want to, my field is running dry, give me some water today or this week, or whatever it is, right? So we thought that the farmer will have more decision-making power with respect to conservation of water use. Turns out that it is possible that the farmers, well, they bought some pipes, but maybe they did not have the associated flexibility to decide when to irrigate. So maybe that information was not useful. Or maybe I put the pipe in my farm, but I see that the water level has gone down, but I go to the owner and I bring it, and they don't give me the water. So yeah, it turns out that the savings were not realized with the that. Also, remember that these guys are not paying volumetric price, so they are paying a fixed per acre fee, which is decided before the season. So we distributed these pipes at the beginning of the season during the seeding season. So the per acre fee is already decided. So maybe I can get more water so that my crop is, the condition of the yield is increased, goes up, but it doesn't make a difference to my how much I pay. So even if the guy is over irrigating, like you were saying, it doesn't matter because it doesn't save me on water. If I get less water from the owner, it doesn't reduce my water charge. I'm paying it back. So many of these things could potentially be happening, but we know why the exposed. We know why this mention made the biggest difference, because this is just net reduction in cost. So the owner pays the tube all the electricity, right? At the end of the season, there's a electricity, the meter is red, and you get the bill, the big bill for the whole season. And so if you use less water, that there's a direct reduction in cost. And therefore increasing the cost.
I'm just wondering, since the pricing structure is different, right? This is the well owners are paying volume, and the other farmers who are buying.
Well owners are paying for electricity.
Right, and
Right.
if the buyers are paying the tax from, the acre land area. I was just wondering, even without AWD in place, the incentive would be to, pump less water by these owners and sell less water? Just.
Okay, hold that thought because I'm going to show you the conceptual framework in a second. That will answer that question. That's it. Any other questions? Okay, so that's the idea. Well, just to quickly tell you where the how much time do you have? Okay, so there's large literature on policy levels for making groundwater sustainable. Very quickly, community monitoring. There's some recent papers on that. I mentioned the Ryan and Sudarshan paper on on rationing. The old papers on water efficient technology, drip irrigation in California. But this paper, what it does is shows how technology can efficient goals, but benefits may only accrue to monopoly sellers. So we are achieving conservation goals, but we are not able to capture who gets the benefits from this. So there is also a large literature on technology adoption and showing that end users are not always beneficiary. And I think there is an example of contract farming in Kenya. I looked at that, what it said, but basically contract farming, conservation efforts, contract farming, there's distortion of incentives. And like I said earlier, hardly any work on ag energy efficiency. Any of you guys are in fertile area. So the context, just to give you a quick context, I think everyone knows, we already explained how the irrigation market is structured, and the owner helps manage irrigation, sometimes irrigates multiple fields at once because of the conveyance costs. By the way, these are all ditches, right? So conveyance costs are large in this setting. So this is our study. Our sort of picture, and so these are per acre, fees. Everyone has electric meters, and we have already covered this pumping costs and the water charge paid in multiple installments throughout the season. Usually, there is a lump sum at the beginning of the season, then there is a lump sum at the end after harvest. That's when we. Okay, and like I said earlier, there is no price discrimination. And there are the large spillover. In terms of conveyance. Okay, so this is a very, very simple graphical framework. So what is going on? So here is answers to the question, what's the conceptual framework, right? So imagine that this is the production function for rice. So why does it look like that? Well, there is some optimal amount of water, Q bar, sorry for the small location, it's hard to see. But this is Q bar. So this is the farmer's demand curve for rice. So the idea is, why is it falling sharply here at Q bar? Beyond this, it is not good to give the rice too much water. And this may not be known to the farmer or the seller exactly how much water to send Q bar, because this is Q bar delivered to your doorstep at your field, right, to the crop. How much is the owner going to send me to get to that Q bar? It's QS bar. Okay, so think of this as a little game where this seller is trying to figure out what the Q bar is, right? And this is a monopoly, right? So we have that's the sort of framework. Effective water is what we call Q bar, the amount of water that really gets to your crop. And that is the share of applied water, which is the QS bar. And why does the monopolist extract all the surplus? Because monopolists can engage in perfect price discrimination. Basically, the profits are maximized, monopolist profits, if I extract everything from the right? So remember one thing though, you have to give me Q bar if I'm the farmer to be able to extract all this stuff. Now, if you are giving me less water from Q bar, I am not going to pay you this whole surplus. I'm going to pay you less, right? So remember that, because that is important. Okay, so we assume that all farmers have the same demand curve. Okay, and this is a reasonable assumption. We have done some testing here with yield dispersion within villages, within command areas, and we can see that the difference, in the log yield distribution is 0.196 between the top and bottom quintiles. Okay, so basically everyone is doing exactly the same thing. Unlike the Ryan and Sudarshan paper, where the differences come from groundwater depth, essentially because in Rajasthan groundwater depth is high and low, and they find differences in the demand curve because of that, because of a bunch of characteristics they extract from. So okay, so this is the idea. Okay, so everyone is identical, and so here is your another picture. So you can see that this is my average cost curve, declining average cost for the farmer. Now, this is the marginal cost, which is the cost of electricity, which is highly subsidized, 5 taka per kilowatt hour. Okay, so to get to Q bar, suppose without my device, I'm at QS bar, right? So basically, I have wasted money with C plus D, right? I've given you too much water. With the AWG now, I can target the Q bar in a much sharper way. Maybe I'm only sending you this QS bar amount of water, then it's going to save me this guy here. Now the question is, what about the money that you are paying me? Well, either way, you're getting Q bar, so you should be happy to give me the surplus, this whole area, this colored area, because you're getting your yield, right? So that's the basic idea here. That's why you see fixed charges, not per kilowatt hour or per gallon or acre foot of water, price in Bangladesh. But it's a monopoly that is engaged in perfect prices. So that's the basic model. So what are the model predictions? So we are trying to write a very simple model, but the idea is actually really simple. So see, we don't know ex ante if we are delivering Q bar or not, right? Suppose, so there could be two situations here. Without AWD, I might be giving you less water, right? And then AWD allows me to target the water really sharp. So I know that I can get more money out of you if I give you Q bar. So if I go from here to the left to Q bar, then what should I observe after my experiment is over? I should observe that your yield has gone up, right? The amount I have charged you has gone up. Okay, how much water? So water charges should increase. Water applied, yield should increase. Water applied may go up or down. I'm not sure, because I could be giving you more water, less water, but I'm getting to the correct amount. On the other hand, what if I'm giving you initially without the device too much water? I'm wasting water, right? Because I want to make sure that you are getting enough water for your rice so I can charge you that money, right? If I give you less water, I won't be able to do that. So with the device now, I'm able to sharpen. So before I was giving you too much water, now I'm going back to the correct Q bar. Then what should I observe? I should observe that I'm sending you less water, right? But yield and fixed charge should not change. Yield should be the same because you got Q bar before. Basically I'm giving you too much water. I'm sending too much water. You got Q bar or a little more than Q bar. And your yield will not be impacted because the rice only needs so much water, right? So essentially, there are two outcomes. One is, if you're getting deficit water before, I should observe an increase in per acre feeds and increase in yields, or I should see no change in yields and no change in per acre feeds and decline in water.
Since the charges are fixed charges, now if the seller chooses to supply less, not purposely, but they're supplying less, they're still getting paid the same amount, or is it?
Well, every year, well, every year they decide. The village decides, or essentially the seller decides. They have to talk to the customers what the charge should be for this year, right? But for example, if I give you less, I'm just thinking operationally, if I give you less water, right? And because of the device, I now give you more water. From the left to here, then your yield should go up, right? And so I should observe that yield should go up, and therefore I should be able to extract more surplus product. Now, what you're saying is how quickly can you change the price?
When the yields increase, the farmers are willing to pay more. So the next year they are willing to pay a higher price for.
Operationally, I don't know. Yes, you are right. I mean, this is hypothetically I'm saying, right? If you get more surplus, monopoly model says, profit price discrimination says, you should be able to extract all. Now, whether in operationally, you're getting more yield. I can observe your yields. I mean, it's a small village. Everyone, actually, 1/4 of them are my relatives. I'm the well owner, right? So everyone, for example, knows the electricity bill of the village, which is surprising. And the bill went down by 40%. Still, there was no change in water charges next year. So everyone knows these numbers are not unknown. If you get a lot of yield next year, okay, then I think everyone should be able to observe that this year you got much more rice. So hopefully that should translate into the well owner charging you a higher price. Now, yeah, to what extent is there friction in the system? That is not clear to me. And maybe we should go back after a long period of time to observe if there are any other, what's happening. But we only observe this over 2 seasons. How old is this?
Since when? What's the time frame?
I'll show you a time frame in a second. Everything was finished in the first year of COVID, 2020. 2018. Yeah. Yeah.
I didn't understand the inclusion exactly. So suppose I'm a owner. If I understood your inclusion correctly, I don't really need data to figure out whether I'm oversupplying or undersupplying. So suppose I'm to the left of Q1 and I undersupply. Your yield will go down. Easily, if I'm to the right of Q1 and I undersupply, yield will remain unchanged. So I don't need AWD to figure out whether I oversupplied or undersupplied.
And so you are saying I have accurate information about what Q bar is.
No, I don't. Suppose I'm an owner, I don't know Q bar.
Right.
But I can still figure out whether I oversupplied or undersupplied vis-a-vis Q. Suppose I undersupplied. I'm to the left of Q upper bar. And I further undercut. So yield will go down.
Yield will go down, right?
Vis-a-vis, I am to the right of Q bar and I undersupplied. Now yield will remain unchanged.
You are to the right of Q bar and you are shipping more water, but you are actually giving them less water.
Yes. So suppose I'm to the right of Q bar and I cut.
Right.
Yield will remain unchanged.
But with the AWB now you have better information. So I'm only comparing with and without AWB. Right? So there are 2 cases, right? One, suppose I have trouble and maybe this. Also, remember that this, in the long run, I mean, there are short-term phenomena like temperature and other things that cause, more conveyance losses. So, this number may be changing, but how much conveyance loss I get in every season may be variable as well to some extent. So it's not clear to me that I'm systematically undersupplying or oversupplying, right? But whatever I am undersupplying, it seems to be the case, and the results I'll show you, is that we are basically oversupplying, and with the device, I'm now more accurately able to find Q bar, and therefore I'm sending them 40% less water. But if suppose I was undersupplying them, with the pipe now, I have better information, right? So it's rational for me to extract give them more water because this surplus is higher than the extra cost of sending water, right? So I'll benefit. In spite of my increased marginal costs, right, I'll benefit by giving you more water if I'm to the left of this. And that's what we don't observe. And then if I'm able to give you more water, I should be able to charge you more money. And like you were saying, it is possible that within 1 year, we have not observed the whole process. We don't know what happened if they continue to use the pipe in years. That would be interesting. But that's what we should observe. Did I?
Yes. Second season, you would not expect a lot of farmers to take up this technology because they're not in the game.
Who in the
The farmers, the buyers.
yes, exactly. They are not getting anything because
You still pay the same price. It's just the seller who's extracting all the profit.
absolutely,
And I
absolutely,
think that's why you said that some people pay with the pipes.
possibly, or yeah, or many of them report it to be lost, and they and maybe they have already figured out in those villages. We asked them, who is the owner involved in your decision making, and about 70%. So this owner is involved a lot in decision making, even at the individual level. So the arm where we sold the pipes to the farmer did not exposed intuitively did not result in water saving. Other questions? So okay, so again, this is also do water prices rise or fall after experiment? Do crop yields stay? Collected information on water prices and crop yields, and this is the sort of practical sort of steps. We took 360 villages in Mymensingh and Kishoreganj in northern Bangladesh, where the water table is relatively shallow, so you have private tube wells, and the Boro 2019, we offered pipe at 30 or 60 taka, door-to-door 105 villages, meetings 105, owner 105, and there's a control group where did nothing. Just go and collect it. And and then randomization is at the upasta level, which is a bigger level than, and then we are targeting subsidies to buyers, collective decision, meetings, and targeting subsidy to water seller. So here is the timeline. So we started baseline at the village level 2018. All the farmers in the command area were listed. There are multiple command areas. We randomly chose one, and then we randomly selected 8 farmers in the command area. And then in January 2019, we offered them. And then a lot of effort was spent in reading electricity. This was like very difficult because some meters broke and then they were replaced. And then, of course, COVID hit and we could not send our enumerators to the village. We had to call them to verify the meter readings. In many cases, we actually obtained the bills. So in many cases, we had to reconcile the numbers and we obtained the bills at the end of the season. Then we did, in 2019, we did first year, we did a follow-up survey. Then we did the same subsidies again in the second year. And then we read electricity meter again. We basically read the meter 3 times in the beginning of the season, when you're seeding, in the middle of the season, at the end of the season. And then we did a follow-up survey as well, which was primarily phone. And here is you can see, I mean, these meters, I spend a lot of time because I know Bangla, helping our students to decipher what yes, I can. Either the plastic is not good or the plastic is bad. So people have to take serious risks reading these videos. Okay, so here is some descriptive and what you asked me that command area. So we have 360 of them. Number of farmers is 16.2, 17, 19, 17 farmers. Acres, you're asking 12 acres, the whole command area. So divide 12 by 16, it's per farmer. And multiple plots maybe. Water price, about 6,500 per acre for the whole field. So you pay about half of that. And half of that at the end. But in general, you may ask and get some flexibility in payments sometimes, and we did a so these are some other variables we use as controls. Yeah. Number of farmers in the command area who receive water from this owner. Number of Bulk supply, monopoly, right? These are the number of customers. Yeah, on average, yes. It's only 16 point. Yeah.
Can predict that we have supply water. Accordingly, we can understand the optimal movement over the time. And also the farmers are not getting any perfect output. So on the very first step, I put the well water by the CWM. What is the incentives for them to have?
Okay, first part of the question, I think we discussed. Some of this is variable, I think. Very hot days, more evapotranspiration, a lot of the water is going kacha, the field. So you have to give more water. I'm not sure there's a formula that is good every year. That's what I think. And the other one you are saying is, what was your question again? The other one?
Farmers are also getting
Right. What?
it might be a short-term benefit for them, but for the long term, it is not going any benefit to the farmers. So, I mean, why would the well owner buy the very first?
Well, I think well owners are very smart. You saw, they bought it and they placed it in the field. We have the data for how many fields, how many were actually installed in the command area. So we can see, that they were smart. They saw that this information, the device gives you information that may help them reduce the amount of irrigation they do. And they were right. So
Just to add to that, owners of volumes.
they are paying the electricity bill. See, all the money they get from per acre, 6,000 rupees, right? Taka. Then they are the guys who are paying the bill to the electricity authority. So if any water use is reduced, it directly goes into their bottom line. Right. Right.
In other words,
Right. So you are saying farmer may be thinking, look, this may actually, we are going to use less water. It might negatively impact my yields.
that's a confirm.
Right. And that may only be relevant in the farmer arm, in the two arms where we target farmers either in groups or individually, but not in the owner arm, because the owner cares less about what the farmer's yields are going to be.
Yes, it is. But
Right.
for these small farms, we may not care because we are.
Right.
You may be neutral to that. Can be different. But cannot be so with you.
Right. Yeah.
So to install these devices in the field, you need the farmer's permission.
We didn't install it, they installed it. Once we sold it, we just took off. It's up to you. You play cricket with it or you install it. And then we go and observe how many have been installed. We give them a little initial briefing, where, basically the eerie sort of standard PR stuff on this has been known not to affect wheels, it saves water, blah, blah. We give them that. But you are right. I mean, I think to the extent that they are worried and therefore they are not. What's interesting though, and I'm trying to think how I can cite evidence that goes against that thinking, is in the meeting arm, as I will show in a second, there's a lot of buying. They buy a lot of pipes. And it's not clear to me why, if you think, maybe they realize later on, or that thought may have come to them after, but they do buy a lot of pipes. And sometimes they also install, but there's of course no impact on ultimately the pipe can sit there, but as if I don't change my scheduling, and if I don't have control over when the water is delivered, then the impact of the pipe will be. No, we did. We did.
The farmers are buying.
Oh, no, we did. We did. There's no impact on yields. No, I am sure you that there is stable.
Can't pay the farmers. That means
Right.
that means also
Yes, exactly.
aspect of the water requirement. Almost like, although they were using over for use of water. This much water at least get the farm and then standing there in the water.
Right.
That's why it is not water.
Right. Exactly. Now, yeah, I mean, the other thing is also, I think, along the lines of what you're saying, why would the farmer be so afraid of yields? If they're all, they know that, this is just giving me more information about the water use. Unless they are afraid that for some reason we will get too little water when we look at information.
That's about this now. First perception of
Right. Yeah. We basically see effects when, it is also, if you're afraid of yields, why would you buy so many? Why would you buy so many? And maybe there are other reasons why. Someone comes to buy or sell something in the village, they're all sitting together and it's okay, it's not that much money. 30 taka and 60 taka, even for a poor farmers. So you say, okay, I will buy it and then. Okay. So this is, some other variables. Here's education, rice acres, herd of AWB. You can see about 0.16 or so have herd of AWBs. Not completely unknown. Livestock, the number of crops. So we use these in our regressions. So you can see here joint irrigation with others. About 0.36, 0.4, 0.35 of the guys are doing joint irrigation, which is actually, your plot is with a group of farmers, then the irrigation happens all at the same time to save on conveyance losses. Owners help. This is what I was telling you earlier. Owner helps decide irrigation. 0.74, 76, 73, 71. So owner has a lot of say in when irrigation occurs in your. That person is optimizing water use for paying for the water. An immediate family of the owner 0.6. So then here is your regression specification. So you have outcomes. Some of them are individual, some of them are division, and you have these arms. So the outcomes could be prices, electricity use is at the village level. Yields, for example, these are individual owners. So you have these three arms: beta one, door to door, and meeting. And then you have some other all these controls that I just showed you, and because there are fixed effects and errors are considered. Yeah.
Yes, only farmers like some of them are willing to buy it, some are not willing. Some of the sellers are buying it on the road and someone who's buying.
Right.
So we have control room and treatment group on that.
No. Every village we sell. We only have one arm in every village. So the command area. Remember, the only one seller, the village, right? We are only targeting in a village. We don't target multiple tube well owners. There is only one owner because we have identified. If there are 2 or 3 command areas, we choose one. Only one command area, one owner. So we go to the owner and say, here, these pipes are available at either 30 taka or 60 taka, depending on which village it is. and how many do you want? That's all. In the village. Farmers, yes. Farmers, yes. Door-to-door farmers, yes. So suppose you take village X, we go there, we are doing door-to-door, we knock and say, hey, guys, this pipe is available for 30 taka. You want to buy it or no? Yes, sir. Yes, some of them don't buy it.
I just don't know how they get that control group. Like for the sellers, some of the sellers will buy that technology, some of them will not buy that technology. Those who are not buying that, only that is the control.
No, the control group in our experiment is one arm where nothing is done. Nothing is done. No pipes are being offered. We just go and talk to you guys and get your data. That's it. Yes.
Across treatment type.
Yes, exactly.
So where there's nothing.
But in that Upazila also we have control group, no?
Then your treatment,
The strata is Upazila level. We within the Upazila we are choosing which villages will get what arms. Yes, treatment is at the village level. Yes, exactly. Is randomized. Very good question. So I'm not going to show you anything. We didn't see any effects. We thought, 60 taka versus 30 taka may have a huge difference. Maybe the 60 taka guys will buy less pipes. They will do some things differently. Maybe price effects will be significant. We didn't see. We just saw more effects on the 30. So, for example, more people bought when the price is lower, the standard demand curve sloping down, etc. But we didn't see anything earth-shaking from the price mechanism. So take-up doesn't vary across farms. We are good with time. I just have a few more slides. Take-up doesn't vary much across arms. More farmers buy at the meetings, but there are no differences in installation. So here is your picture for year 1 and year 2, and you can see this is year 1, buy, install. Okay, and the comparison is the mean outcome in door-to-door. Okay, when we knocked at individual doors. So you can see the door-to-door guys, 10 of them buy. You remember how many farmers were there in door-to-door? Yeah, good. So we passed the quiz. Okay, so it's 10.65, right? See, in the meeting, about 20% more people bought, which is nice, right? So it's a meeting effect. Everyone gets energized and they buy. Install. How many people installed in door-to-door? 4. We saw 4 pipes in the fields. So we had our guys look around and see where you can find these pipes planted in the field. 4. So basically they wasted, or 6 were cricket bats in the village. Whatever, they lost it. Something happened. Install, not significant. Buy, we went second time again and say, guys, you need more. We have the same, more pipes at the same prices, 1.6 on average bought in the door. And then meeting again, there was more people buying, but much less than what we do, much less than buying, right? So it's clear that they're just basically wasting the. So here is your plot level results. So we randomly, if you had multiple plots, we randomly chose a plot. And you can see plot level usage of AWG, control group here. And this is control group. We didn't do anything, but we may see, 1 or 2 odd characters have a device. But here you can see that these guys, of course, have way higher usage. And you take out the control, then this is the treatment effect. So year 2, again, the same, maybe a little more. You saw one, well, actually it's 0.1. So you have higher adoption in the technology, but not more usage. And across all treatments, pipe more likely to be placed on plots of owner's family. So which plot would you choose to locate your pipe? In general, across all treatments, I go to my buddy or my uncle or my nephew and plant the pipe or ask them to plant. Okay, other villages, less. Okay, so now this is the exercise I told you that consumes our energy. This is a formula for measuring electricity use. Meter, final meter reading minus original baseline meter reading. Now, these meters are only used for rice, boro rice. They are not used for summer season. They basically lock them. At the end of the season, they are under lock and they are opened again next year. So meter, final by minus meter original, divided by the date, so number of days, times the harvest minus plant date to get an accurate estimate of the actual duration of the cropping season. So if our final reading was after harvest, then we use the harvest date. And if our baseline reading was before, we use the plant reading. So in a few cases, we read the wrong meter at baseline, and then we have to use the pictures of the electricity. Yeah.
They have electricity on all the villages.
Do they have what?
Electricity
Yes.
in all the villages.
Everyone.
By the government.
Yes. Government. Yes. It's subsidized electricity. It's 5 taka per kilowatt hour. I don't know what the comparative electricity bill in agriculture in India is, but I think it's much less than social marginal cost, which might be, I don't know, 15 taka, right? I know in the US, pardon me? Oh, zero, right, 0 and something. Okay, so here, during year 2, the intervention lowered electricity for groundwater pumping by 38%. So here is our picture of electricity use. You can see that mean electricity in controlled villages is 5,000 kilowatt hour, 4,600 the second year. And you can see door-to-door reduction, heating reduction, owner reduction in year 1. But look at year 2, 0.478 reduction, which is large. In the meeting also, there was some reduction. And you can see here, the p-value for door equals owner, they are not. So the average is, so this is in logs. We also had the same results in levels. So this number, 0.478, use that formula, basically boils down to about 38% savings in it.
Can you explain please by where I know these are related. Essentially internet benefit where I choose to install my machine. So if I'm installing it in my neighbor's place, I expect more reduction, but because it's easier for me to then gather that information, put that field, check what's the level that is required, have better.
You mean the owner installs in the neighbor's place?
Yes. But the reduction might be lower if I'm installing it in my relative's place, because I might be then transferring some of my profits to them. You know, there might be some cost sharing in terms of getting that technology, and then I'm also passing down some of my profits. Saying that heterogeneity can also be explained.
So, but why would you do it in a neighbor's place and not in a relative's place? What would be the
It
relative?
could be intersection as well. So,
Right.
people who are close to me are also
Yes,
relatives.
yes.
So I mean,
Yeah,
interesting insights for the knowledge.
yeah. Where exactly locationally? Where do
Because you
you
have that information.
we have that information? Yes, yeah. That would be interesting. Right, right. We did look at the correlation between, I think where you planted and the electricity savings. I didn't think we had any clear effects, but yeah, that's a good point as well. Beyond looking at whether in your relatives. Yes, 38%. Yes. So ballpark about you take about 20 irrigations in the season, 20 to 21, 22. So they probably came down by 15, 16 maybe.
Not related to that. So if suppose the neutral is that's the farthest field. There are channels that is combined stuff. So something happened to friends. I supply to the
Yes.
because if I can now observe at the far end that they do that. Therefore, I cut down the friends I supply.
Right.
You might actually avoid because the conveyance loss is gone. There's use
So you are saying they may be getting less, they may even be getting less yield. Well, if they get less irrigation.
but if earlier I was supplying say 3 times to the regulating, but they didn't need more than that because they were getting.
Yes, yes.
But now the conveyance loss has gone down. They actually need a 4.
Right. Because I'm not shipping that much water, and therefore the percolation into their fields as a externality or as a spillover. The spillover effects.
So
Right.
it's kind of a difference. Where the father and guys actually stay reduction. Guys in the are actually environment.
So you are saying that, yeah. So you're saying that the farther guys maybe you are saving water on those guys, right? But the in between guys are now getting less water. But if you look at the yield effect though, now I'm saving water on the farther guys, but the yield is not impacted because I've just reduced my losses. But the in between guys, the yield should be impacted unless they are also getting too much water because the water is passing farms every time, right?
Is it the same charge of respect when
Absolutely.
it's the same charge?
Absolutely. This is an important point also. It's the same charge issue because technically it should not be. But efficiency reasons, the corner person should be paying more because I'm spending more water to send water to those guys. But in a village, it's not feasible. And then immediately you open up a can of worms because now the person in the middle basically benefits from all the shipping to corner people. So then you are benefiting, so you should technically pay for those benefits.
But
Yeah, unless you pipe it. Yes.
I'm saying what is the direct the direct automated in selling the technology
Directly to the farmer. Directly to the farmer, which has no impact.
there's
Yes.
no impact.
That is the yes. In the literature, the subsidy is always the user, narrowly speaking.
Even that sites when just to mention that is a dead loss. Then as opposed to the benefits that we
Yes. Percolation.
population,
Right.
different types of clarity. There is no technology to this.
Good.
Transpiration, like transpiration is gone. For the macro,
Yes, you mean like here.
it is 4.9 versus 4.6.
Right. Yeah. From year 1 to year 2.
Year 1 to year 4. So that would be the whether you are
Well, yeah, whether other things, yes. Yes, exactly. There are some things that may be changing from year to year that leads to that's a good observation, yes. But of course, this is the peak.
so which also explains why you are getting it. Because here and now I can observe they actually don't need that much. So I cut down.
Yes, yes. So what you're saying is some of this may simply be non-AWD type issues that have
There
reduced.
would be an AWD
Right.
there, but only if there is a clear requirement. For example, here you see that general usage is gone. That not collaborated. And in those, I I can actually observe that it has not gone down. Therefore, I actually.
Right. Yeah, there is a lot of heterogeneity within the village where some of this is taking place.
That is that the command area.
No, well, location, like you were saying, location is the basic issue.
No, these are not like in America.
Right.
These are size maybe acre or point.
Absolutely.
And the total command area of this. More than
15 acres, right? Right.
Yes. This command. For this. This
But here,
Right. Exactly. Okay. For both years, if you take the average, it's about here also a significant owner. This shows that basically at all levels of electricity use, you have significant owner effects. And then there is lack of acceptance in some villages, and that may make the first year results noisy. But I want to show you a few more things here. On 4 minutes, okay. So we did some robustness, electricity levels. We took out the controls. We, about 20% of the electricity data was missing because of COVID. So we made sure that the missing data was not significantly different across all arms. So that was important. And then what doesn't seem to be explaining differences across how subsidies are introduced? Well, it doesn't seem to be take-up. Obviously, take-up was higher in the farmer settings. No more likely to be used by owners, family, friends in owner villages, and where the pipes were placed. And then here we find evidence that this is important. I think we find evidence that when subsidies are targeted at owners, they are more active in using the pipe. So the owner, when in the owner villages, they are now much more active in water management, because we asked them in the question, well, between different arms, who is overseeing your pipe management? Okay, so farmer, well, in the meeting it is farmer, effect is positive. Owner, it is slightly negative. Family, owner, you can see the owner arm. The owner is much more involved in the management of the. This is all of the farmers, not just the owner. And then we also asked alignment. And then, so here is the other one. Owners pay for electricity, AWP subsidy causes bill to fall. To farmer level outcomes respond in Y2. This is important for the theoretical. We are checking crop yield because we expected crop yields not to change. Per acre water prices, if full extraction by the monopoly, then per acre water prices should be same. And then we actually quiz them on credit payment flexibility. Like, okay, share of growth, we calculated. So every farmer, we asked, how many installments are you paying and when? So we calculate the share of total water bill paid by farmer during second half of season, because the farmer's job is to postpone the payment, because that's when I'll get cash, right? Basically say, hey, I want to pay after harvest, not before, right? So we calculate that this share of the total water bill installment that you pay during second half. And one way to share this obviously is more. So the point we are making is that, look, owner is making more money, but are there discrete ways in which owner is passing this surplus to the farmer? One way will be, guys, pay me later. Now that I'm richer, right? So is that happening? And we see no evidence that farmers see short-run benefits, and that they negotiate more. So here is payment flexibility. There is non-significant results. Now the three arms. Water price does not change at all. Price yield, no change. And then finally, we basically said, well, how many people have you talked to? So we say, how many number of farmers you have spoken to about irrigation, a number of farmers who have negotiated with the owner. And you can see that in the owner arm, more farmers are negotiating with the owner, which is exactly should be what is happening, because now the owner is saving money. So I can go and ask for a different price, and that we see some evidence of that happening. Okay, social benefits. So here we go. I'll wrap it up really fast because we are almost over time, right? In 30 seconds. But basically, the idea here is that, you know, we calculate the dollar cost of reducing carbon emissions through selling to the owner. So remember that the farmers also bought a lot of pipes. But if you take the cost of the pipe, it's not a good investment because you're not saving much water and you're buying a lot of pipes from it. Owner is good because owner, you said they buy few pipes, but they are getting a lot of bang for their buck. So we compare the cost per unit of energy saved from intervention with various energy efficiency interventions from the literature. We look at, you know, and we focus on the owner subsidy for 2 years. And this is a calculation basically saying, look, Bangladesh, you know, most of it is coal, and how many CO2 emissions per kilowatt hour. So we calculate this and say our savings are 2,400 kilowatt hour over 2 years. 13 pipes are sold in owner villages. The cost from the survey is $62 per pipe. So we assume $10 delivery cost. So cost per kilowatt hour is $7. And then we look at this cost relative to other studies. This blue line is our cost. And these are all the other studies from various energy economics studies, RCTs, and experiments. And you can see this is really good. This is really good because it's much cheaper to reduce emissions to the AWB pipe relative to other mechanisms, especially in residential use. Almost everything is residential for this paper. And so what we do is we say, look, take the grid emission factor in Bangladesh, 1.47 pounds CO2 per kilowatt hour, and our treatment effect is 1.6 million tons. So the social cost is 25.6 per ton of CO2 avoided. And what we do not include is methane benefits because AWB apparently reduces methane. And in a previous experiment, we actually mounted a methane experiment. It turned out to be really costly. We had these glass boxes in farmers' fields, like I think 1,000 of them. Yeah, but it took 4 months. There was only one lab in Bangladesh that can measure methane. So we gave them all the vials, took them 4 months to measure, and all the methane I think had leaked out already. Those vials. So the effect was null. There was no impact on WB and methane. But methane benefits are very significant. And we also do not calculate the cost savings from the power not generated. So anyway, that's basically it. The takeaway is that local water markets are common, right? Efficient irrigation methods are also very common, but we look at this, these issues with respect to energy efficiency in agriculture. And the problem is the benefits go to the monopolists, and there are no immediate benefits to farmers. But of course, the environment wins. So the water sellers win, and the environment wins, but the average farmer does not win to the extent that they are benefiting directly from the environment, but not directly their pocket. And so the takeaway is that end user may not always be the beneficiary of agriculture. Okay. So thanks very much for your comments. Those were very useful. Happy to answer more later on.
Questions or comments anybody has?
Yeah.
Why we particularly focusing on electricity consumption, not looking at the extent of groundwater? That's the purpose of reduction of energy. Hard to measure, and that's why you focus on it.
You mean measure the water use? In a previous experiment, what we did is, yes, because it is not, how do you measure it, right? I mean, there's no way unless you go to the mount of the pump and, install some device. What we did though, we had two metrics for measuring. That time we did measure water use. And one of them was we randomly visit the fields at random dates, okay, and put a scale and measure the amount of standing water. And also answer another question, 0 or 1, is your field dry? Is that field dry? So these two metrics turned out to be good descriptors of water use. And we found in that paper, it's published, that in the AWD fields, there was more times they were dry because they were able to use the pipe. Right. So, again, back they were probably putting too much water, but now with the pipe, they are able to go down and water accordingly. So that's how they're saving the 30% water. But in this case, we decided electricity is a good measure because, we can really nail down how much electricity is being used. And
Nice because it also has distributional implications. The average farmer is not gaining, but the owner is gaining in terms because it's a monopolist.
right.
That in that sense, the distributional implications are nice.
But right. Context of this. Terrain rice is what we do. Best not be that serious. Is that true? Statement I'm not.
You are absolutely right. I mean, well, the problem is, I think at the end of the Boro season, you are already down quite a bit and you have to wait for the monsoon to come back. But in terms of dollar values, though, we have done the exercise of calculating the value of the water savings versus the value of the electricity savings. Almost 10 times lower for water. Yes.
Part is of course very taken.
Right.
The greenhouse gas.
Yeah. Yeah.
The water that is being extracted and recharged back in basic. Isn't that true?
It is true, and 25% in water is lost. We did this exercise for the earlier paper. So obviously some of the water comes back, right? Water cycle and so forth. But the value of the water, if you take foregone future production and all that, it is about a tenth of any reasonable social cost of carbon estimate that you want to put on the carbon. So it's 10x the difference, 10 times.
The social benefit addition of people.
Exactly. So it's 10 plus 1. Yeah, absolutely.
But is the groundwater level going down?
Yes, but you read all these, you read all the literature. Everywhere is going down.
Yes, but in the context of the area in which is
that is in this area? I don't know. I honestly don't know. In some areas, it is pretty bad.
Yes,
Right.
You're spending time
well, I other ecological kind of studies.
Well, some areas, barind areas are really bad where the individuals cannot even sink those powerful tube wells. The government has intervened. But in this area, we have not heard, like wells going out of operation, like, okay, no more water anymore. Now we have to be somewhere else.
In the large parts of India, we have a serious problem for use of water. That's
Bangladesh being at the end of, all this flooding and so forth, I'm suspecting that the water is not a Rajasthan. Right?
yes, but only that sugar cultivation has actually possible
In India.
comes around the policy and so.
Right.
Separate question together. That
Probably relevant to Bangladesh. Well,
in this context of price set.
one of the interesting points about rice, by some estimates, 55% of the world's irrigation water is used on one crop, rice. So I call it the evil crop. It's good to eat, but it's really terrible in terms of its resource.
It's a very interesting problem. But that is in part. And the greenhouses that have in this happens. Probably I had that long time back for this problem. environment. In during the day. That is a question that I was asked. Kind of areas that are there any other studies?
Well, what you hear is like salinity and those types of things in coastal areas. Yeah, yeah. No depletion. I have not seen. I mean, to the extent that the ministers are going around the country and saying, do not grow lentils or mustard and other stuff. Do not grow boro rice.
Salinity ingress can actually
Right.
area
Right.
because of the temperature
Yes.
coming in.
Yes.
That is a
But the political folks are also very, very interested. But the other interesting thing is, Bangladesh really believes in AWD. So now what we are doing is we have a grant where we are basically helping the government target training to areas where, we are firstly telling them target the owners. If you really want to save water, forget about the money they are making, that's okay. But at least you're going to save water. So target owners for your training, AWD training. Don't target these, they go randomly in every village and catch hold of some farmers and train them. And so the impact is zero, right? So do that. Target owners. And secondly, target those areas where in the deeper areas, Parind areas where there's a lot of debit cards. So target areas where farmers have debit cards because they are essentially paying volumetric pricing. And so they will be willing to plant these pipes in their plots.
final question for me. This is a meeting. How policy can you in natural? Probably definitely from the anything. I mean, things.
I mean, you
You
mean force the seller of water to share the surplus.
No. It's a bit like the zamindar system. Hey, that's it.
Well, I have gone and asked tube well owners and took them aside and say, hey, I know you're saving a lot of water. Would you think you'll lower the prices next year? Then they start giving me a long lecture on how expensive it is. And
That question can be answered.
Right.
If somebody is not was
Right. Right. Fundamental theorem.
Understand what is the nature of it. Here, it's per hectare. Per hectare per irrigation.
No, per season. Yes, before at the beginning of the season, there is a price, there is a number that comes out, 6,000 taka per acre. You have 2.2 or 1.6, you pay correspondingly, and then the question negotiation is, well, I'll pay in 2 installments versus 3.
So you're saying how many times?
No, you don't say, absolutely not. You can't, because it all depends on, hot days, hot spell, you're going to irrigate more. The water seller's job is to make sure you get your yield and there is no stress on the crop. Yeah, he's extracted as a right. But in the
therefore know the price. Doesn't know.
if he's saving, his bill is 30% less.
So not that 6,000 taka is not like this.
Oh, of course it's crazy. But these guys did have a reduction in the bill, right? Because we read the water, the meter readings. They got the reduction. The village knows that they're not. Hey, last year you paid 30% less. There should be a campaign or some some pressure to say, hey, come on, let's negotiate because I know you made less, higher profits last year. Yeah, that's a good question. Yeah, that's a really good question. Yeah.
The owner is only paying.
Yeah. Lineman has to go and look at the meter and so forth. Yeah, there is some increased cost. It's probably a small amount compared to the whole.
Because they can,
Yes.
on that.
Cost of storage of the pipes. I've seen owners nicely at the end of the season tie the pipes in a string, put it in some nice place. Sorry, you had a question.
I'm just want to understand. But is that better to target? But if you get a pre-line down here.
Right.
For 4 years. But the line is not different about the treatment as compared to for the control. So if you those possibility, irrespective of whatever as long as the treatment is happening, what the decline is not statistically. So we are coming up with that
Door is equal to owner. This is significant, right?
yeah, but that's 9 years.
Yeah, in the combined year it's not significant, right?
So it does not matter what happens. Yeah, so this is, but there was a conclusion that you are saying that it's better to target the owner.
For both years together. Right.
And that's interesting that may not.
Right. Because I cannot rule out owner equals door. Or
What's happening is that, as you're moving along years, right? In the first year, you don't see that difference, but in the second year, you're seeing. So probably, the study is only for 2 years, but as you're moving along, as you give it more time, you're seeing that there is a difference in the odds.
so to the extent that the third year is going to be higher, then you're basically saying we don't trust the first year because there are piece of learning and therefore the second year. Yeah, maybe one have to put a caveat, but your conclusion is correct. That if you look at the 2 years in aggregate, you're not not able to say that. This is one of the problems of randomized control trials, that there is so many conclusions drawn with 2 years of study. There is a big study came out from Kenya in the Journal of Political Economy on they went to poor people and said, we'll connect you to grid electricity at subsidized rates and 4 different prices. And they found that no one is, the take up is very low. So they concluded that electricity has no impact because willingness to pay is low. But the problem with electricity is we think that there is big impacts of electricity in the long run, but in the short run there is not much because you don't even understand. Well, the electricity has come, but what do we do? Should I really buy it or not? So what is interesting in the literature is in the short run, no impacts. Long run, large impacts. There are many studies of electricity on over 5 decades which show huge impacts. We know what it is, right? If Mumbai had no electricity, would be a different city today, right? Very intuitively. But the economic studies are showing no impacts in our city. Another study on India also shows no impacts. Also, I think maybe coming out of the chip. So similar problems. But I think you're right. We have to be careful in saying that it's the second year impacts that are done, not the summer. Right. Yes.
And the question is how in that, like you say, like we're playing as a bag, but still there are effects, and these effects are not significant. Doesn't that require more explanation?
It is possible. Yes. Why are they buying?
Cost. I mean, why is the same?
Right. Why exactly? Why is it right? No. That's a really good question. Don't have a good answer to that. Yeah. Even the meeting guys were scared electricity. The second year.
He's talking about a meeting.
0.304.
Or something. Then, oh,
Oh, there. No, that is behind IGID or something. It's not our slide. Well, thank you very much. It's really good. Good questions from the students as well. We enjoyed it. Nice meeting you. Oh, thanks.
RCP is done and we're ready to submit.
Well, all we are doing is adding some rewriting and how to target, and adding a little concept. The graph I showed you,
Right.
you can put it in mathematics
Right,
terms,
yeah.
to show that there are these two outcomes,
Right.
and then we'll see what happens.
I just noticed on your website, you also have an interesting paper on distance to forest and using forest.
Right.
Yeah, so I work on a little bit on Forest Rights Act, so I was kind of interested in the data that you use. I guess you use Forest Survey.
ISDS.
ISDS, but I think few.
Right.
So I haven't been able to read that paper fully, but I will, and in case I.
Oh, I love to. We have. I'm doing some other work now with. We have some common property resource data for 1998 survey. With the 1990 NSS survey, so we are using that. We have a student at BSc.
So common property. So what does that include? Of forest and
Everything. There are like hundreds of products, and it's a cross section.
So what is that? Like, what are the kind of questions that are asked?
Well, the question that in the survey, it's like, how much do you collect? What do you collect? What do you have? Household, all the other household, your size of land, assets, and how much do you, and income, and then how much do you collect? So we are not really quite sure what questions to ask, but we are playing the data to see what might be. Yeah, no one. What kind of data do you use?
So for my purpose, I looked at Forest Rights Act. For that, I looked at Forest Survey of India, and I wanted to understand, how Forest Rights Act, when it comes up, what is the impact on political participation of scheduled tribes, basically living around forest areas. I've also looked at what happens to land disputes. Because there's this issue around, acquisition but scheduled tribes, forest dwellers do not have formal titles, land titles, but after FRA, they do have formal land titles. So I look at land disputes, and there's a database, a novel database, which is not being used extensively. Land conflicts watch. They collect information on land disputes. That's what I use, but I'm also interested in looking at forest fires and the impact of this, property rights over the common pool resource and the impact of that on forest fires, because, you expect like to, Austria. You mentioned her work, so I want to look at what happens when you have better monitoring community.
So do you use the Moody's data set?
Yes, I have that data, compiled that data set. I just need to now run a basic.
I have a student who was working on that. He did a thesis on forestry and conflict, but it's in Africa because you have this conflict data, right?
Yeah, I would love to.
ASLED. So he did a thesis, but I'm now trying to expand that a little bit and try to into a paper.
Is it available?
No, I'm not put out anything, but we're still work in progress. The whole idea is, do forests increase conflict or in a more general sense for Africa? But because there's a lot of literature on like mining in Africa and conflicts,
even in India,
but nothing on forests.
Nothing.
On more general.
So I look at, one of my PhD papers, I looked at the impact of a decentralization initiative in forest areas. on Maoist incident.
Oh,
So it's in JDS.
okay.
But I'm really interested in issues around forests, issues
Right.
around
That's
security.
really interesting. Yeah.
Yeah.
Where you do your PhD?
Ocean market.
Oh, yeah. Oh, that's really interesting. I should look up.
Yeah, I mean, I have 3-4 papers on that, but I'm planning to do more work because I don't think a lot of people work in this
Right,
area.
right.
I feel
But also, Modi's I have not seen much use in India.
no. So there's she recently graduated, Prachi Singh.
Oh, yeah, I know Prachi.
Yeah. From,
Yes, right. And
yes,
she's in England
she
now.
works
Right.
on.
Right.
But nice to meet you. And if
Yeah,
I
me
have
too.
any questions about your work, I'll
Yeah, we're delighted to. Yeah, okay. Thanks. Okay. Hello.
Would you like to have some chai, tea?
Yeah. There is chai over there?
Yeah.
Okay. Yeah. Thank you. Bye.
That is most